The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, boy, I can't talk at all, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay. So eventually we're going to go on to section 10.2 part 1 today, but before we do, are there any questions from yesterday's section 10.1? Anything that you'd like to look at now?
Yeah, Mr. Mayo, number 4, number 5. I had to leave the meeting early yesterday and I was looking on YouTube to watch the rest of it.
Yeah.
But it was not.
Right. Okay, so can you just give me the problems or do you want me to look them up? What do you want
I
to do?
can give it to you.
Okay, so this is from 10.1.
Yes.
Number 4. All right, what's the question?
It is to find the 2 solutions,
Okay.
possible solutions, and it's the quantity of x plus 8 to the square root of 2 equals 4.
X plus 8 to the square root of 2.
Or parentheses and then 2.
Oh, okay, there's no square roots there. X plus 8, the quantity squared. Okay, and then what?
Okay, so equal 4.
And that's it?
Yeah.
Okay, so it's already in the form we want, where on the left side of the equation, there's a perfect square with a variable involved. On the right side of the equation, there's a constant with no variables. So we'll take the square root of both sides of the equation. When we do that, we put the plus or minus on the right side. So now I get x plus 8 equals plus or minus, but the square root of 4 is 2. Okay. Now, to isolate x, we're going to subtract 8 from both sides. So I'm going to get x equals negative 8 plus or minus 2. So x equals negative 8 plus 2, which would be negative 6. X equals negative 8 minus 2, which would be negative 10. So x equals negative 6 and negative 10. Those would be your 2 solutions.
Okay. I had negative 6, but I was putting a positive 10.
Sorry?
I had the negative 6 right, but I was putting a positive 10.
Ah, okay.
Yeah, okay.
All right, and then you said number 5?
Yeah.
Okay. And what is
and it's the same thing, but it's the parentheses t plus 6 parentheses and then squared equals 36.
Like that?
Yes.
Okay. Again, it's already in the form we want. So we'll take the square root of both sides. And we'll get t plus 6 equals plus or minus the square root of 36 is 6. Then we'll subtract 6 from both sides of the equation. So t equals negative 6 plus or minus 6. So t equals negative 6 plus 6 would be 0. T equals negative 6 minus 6 would be negative 12. So t equals 6 or negative 12 would be your 2 solutions.
Okay.
Any other questions?
Will you still be uploading that video for yesterday's
It's
class?
there now.
Oh, okay. Thank you.
Yeah. Again, any other questions before we go on?
I don't really know how to do question 6.
All right. What's it say?
It says let fx equal in parentheses x plus 5 to the second power. And then for what values of x is f of x equals 2?
All right. So what we're going to do is we're going to take that and put it right there. So our equation becomes that. Are you okay with how I got there?
Yes.
So now it's in that nice form. We'll take the square root of both sides of the equation. And we'll get that. We'll subtract 5 from both sides. So we get x is negative 5 plus or minus the square root of 2. So x equals negative 5 plus the square root of 2, comma, -5 minus the square root of 2. Those would be your two solutions. Okay. And
Oh,
as I
yeah.
mentioned yesterday, and you'll see this in the video if you watch it, this is considered correct notation, but WebAssign doesn't accept it, so we have to split it up into two separate answers. Okay. Okay with that, Sage?
Thank you.
Yeah. Any other questions? All right, then we'll go on. Today, we're going to look at something called the quadratic formula. And how it comes about is a process that we don't cover in this class, so I'm not going to go into details. I'm just going to say, here it is, and then we'll look at how to use it. Basically, if you have a second degree equation, or what is also called a quadratic equation, its general form would look like this: ax squared plus bx plus c equals 0, where a, b, and c are the coefficients of those three terms. All right. When we have an equation in this form, where it's a second degree equation, we can solve it using what is called the quadratic formula. And the quadratic formula looks like this. It says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And it looks pretty horrendous, but it's a very handy tool to use, and we'll be using that today. So that is known as the quadratic formula, and you should work on having that memorized, okay? All right, now, so we're going to go about using that to solve some equations. So I'll keep referring back to it. Okay, so here is an equation. It says x squared plus 3x plus 2 equals 0. This is a second degree or quadratic equation. It's in standard form, that is descending powers of the variable, x squared, x to the first power, no x at all. So it matches the form up here, okay? Once it's in that form, now I can go through and identify A, B, and C. The leading term, x squared, has an implied 1 as a coefficient. So for this problem, A is 1. B is 3, and C is 2. Any questions about where I got A, B, and C? All right, so now I'm going to take these numbers and put them into this formula in the correct places. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now it's a matter of arithmetic and using order of operations. So continuing to simplify, I get x equals -3 plus or minus the square root of 3 squared is 9 minus 4 times 1 is 4 times 2 is 8, so -8 all over 2 times 1, which is 2. Continuing to simplify, I'm gonna go over here and make sure I have enough room. X equals -3 plus or minus the square root of 9 minus 8 is 1 over 2. X equals -3 plus or minus the square root of 1 is 1 all over 2. So now I'm going to split that up into two separate solutions. X is -3 plus 1 over 2, and x is -3 minus 1 over 2. Splitting up the plus or minus, well here, -3 plus 1 is -2 over 2 is -1, and here, -4 over 2 is -2. So x equals -1, and -2 would be the two solutions. Any questions about that? I'm going to go back and take these two answers and plug them into the equation to check my work. So I'm going to go to the next page. X squared plus 3x plus 2 equals 0. And we said that x is -1, -2. If x is -1, we would have -1 squared plus 3 times -1 plus 2 equals 0. -1, the quantity squared, is +1. So we've got 1 plus -3 plus 2 equals 0. 1 plus 2 is 3, minus 3 is 0, 0 equals 0. So -1 checks. Let's check -2. -2, the quantity squared, plus 3 times -2 plus 2 is 0. -2, the quantity squared is 4. 4 plus -6 plus 2. 4 plus 2 is 6, minus 6 is 0, 0 equals 0. So both solutions check. So we've taken this second degree equation and solved it using the quadratic formula. Any questions before we go on to another example? All righty. Let's see here. X squared minus 18x plus 81 equals 0. This is already in standard form. So A is 1, B is -18, C is 81. So X equals -B plus or minus the square root of B squared minus 4AC all over 2A. So simplifying, X equals, well, a negative times a negative, that would be a +18 plus or minus the square root of. Notice here that the -18 is squared. Since the negative is part of the base, negative times negative is positive. And I think 18 squared is 324. Let's see here. Yes. So this is going to be 324 minus 4 times 1 is 4, and 4 times 81 is also 324, and that's all over 2. So then we've got x equals 18 plus or minus the square root of 0 over 2. X equals 18 plus or minus, well, the square root of 0 is 0 over 2. So x equals 18 plus 0 over 2, 18 minus 0 over 2. Well, 18 plus 0 is 18, divided by 2 is 9. 18 minus 0 is 18, divided by 2 is 9. So in fact, we get two identical solutions. There are two solutions, because, as is always true with a second degree equation, but they happen to be the same. So we could say x is 9, and let's see. This author says a repeated solution. Okay. Repeated. I can't read my own writing there. Any questions there? All right. Another example coming up. Let's see here. We have 6x squared minus x minus 1 equals 0. This problem is also in standard form. So A is 6, B is -1. There's a -1 in front of the x, and C is also -1. X equals -B plus or minus the square root of B squared minus 4AC all over 2A. Simplifying further, x equals 1 plus or minus the square root of -1 squared is 1, minus 4 times 6 would be -24, but then times a -1 would be a plus 24 all over 12, which is x equals 1 plus or minus the square root of 25 over 12. X equals 1 plus or minus 5 over 12. So x equals 1 plus 5 over 12. X equals 1 minus 5 over 12. 1 plus 5 is 6. 6 over 12 is a half. 1 minus 5 is -4. -4 over 12 is -1/3. So x equals 1/2 and -1/3. All righty. Let's take a look at this next problem, which says 2x squared plus 7x equals -1. This equation is not in standard form. So the first thing we're going to do is get it into standard form by adding 1 to both sides. So we get 2x squared plus 7x plus 1 equals 0. Always get it in standard form before you extract a, b, and c. So now a is 2, b is 7, and c is 1 respectively. If at any point I'm going too fast, you need me to slow down, yell at me, happy to go slower. All right. So now we've got x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals -7 plus or minus the square root of 49 minus 8 all over 4. X equals -7 plus or minus the square root of 41 all over 4. Now, the square root of 41 doesn't simplify any further. 41 doesn't contain any perfect square factors other than just a 1, which doesn't get us anywhere. In fact, 41 is prime. So that's as far as I can go to get exact answers. So my two exact answers would be x equals -7 plus the square root of 41 all over 4. X equals -7 minus the square root of 41 all over 4. See if I can clean that up a little bit. Okay. So these are the two exact answers. This particular problem, the directions say solve the equation, which we've done, and then it says approximate the solutions to the nearest hundredth. So we're going to go beyond this, and we're going to find decimal approximations to the nearest hundredth. But now I want to look at how we're going to do this, okay? Let's take this first problem. To enter that into our calculator, we need to be careful that we divide the entire numerator by 4. So on your calculator, you're going to start off with a left-hand parenthesis. Then you're going to put in -7 plus the square root of 41. Now, some of your calculators, when you put in the square root, it automatically gives you a left-hand parenthesis. If yours does that, you need to close up that parenthesis, but then you also need to close up the entire numerator and then divide by 4, okay? Because if you don't have this second set there, it's going to think you're only dividing the square root of 41 by 4, not the whole thing. So putting that into the calculator, parentheses -4 plus the square root of 41, close up the square root, close up the entire numerator equals divided by 4, and I get, let's see here, what do I get? Where are we here? It helps if you put in the right number. I put -4 instead of -7. Okay. I'm getting -0.1492189, et cetera, rounding to the nearest hundredth. We'd go to the thousandth place. The 9 would round up. Oh, and I've messed up here. Hang on. I wrote that in the wrong place. I wrote that down by the bottom one. So let's go back here. What I'm getting for this answer is x is approximately -0.149218. So again, the 9 rounds up, so I would get that. So -0.15 is my answer for the top one. Okay, now let's take a look at the bottom one. So again, parentheses -7 minus the square root of 41, close it up, divided by 4, and that gives me x is approximately -3.3507. So the 0 rounds down, so you end up with -3.35. So what did I get? I got -0.15, -0.15, and -3.35. Those are my two solutions. If you have a calculator with you now, I suggest you go through and verify that you're getting those answers. If you're not, if you're having issues, talk to me and we'll go through things in more detail. Okay, we're going to take a look at another equation here. Are we good to go on? Okay, let's see here. This says 4w squared plus 1 equals -6w. So now we have a second degree equation, but instead of the variable being an x, it's a w. So I'm going to add 6w to both sides of the equation in order to get it in standard form. So now a is 4, b is 6, and c is 1. Now, when I first introduced the quadratic formula, I said, actually, let's go back further. Let's see here. I said x equals, well, that's because that equation had x in it. So technically here, I would say w equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, there's even a great song to learn it. It goes like this. -b plus or minus the square root plus or minus the square root of b squared minus 4ac, b squared minus 4ac all over 2a, all over 2a. Thank you. Thank you. I know what you're thinking. Keep my day job. Okay, so what we've got is this. W equals -6 plus or minus the square root of 6 squared minus 4 times 4 times 1 all over 2 times 4. Okay? So W equals -6 plus or minus the square root of 36 minus 16, 4 times 4 times 1, all over 8. W equals -6 plus or minus the square root of 20, all over 8. Okay, now I can simplify that to some degree. The square root of 20 is the square root of 4 times 5, which would be 2 square roots of 5. So then I get W equals -6 plus or minus 2 square roots of 5 over 8. Okay. Now, this is where things get a little bit complicated. We're going to simplify this answer further. And what I want to point out is that both terms in the numerator and the denominator all are even. They all have a common factor of a 2. Okay. So what I'm going to do, first of all, I'm going to split this up. Okay, are you seeing what I'm doing there? Both terms in the top divided by the 8 in the bottom. Then I'm going to reduce it down. Now, what happened to the 2? The 2 over 8 reduced to 1 over 4, and I don't really need the implied 1 out in front. Okay, so what I've got here is W equals -3/4 plus or minus the square root of 5 over 4. You could even go back now and rewrite it as -3 plus or minus the square root of 5 over 4. Now, since they've got the same denominator, okay. Now, I'm going to take that and write that on the next page. W equals -3 plus or minus the square root of 5 over 4. Before we go on, any question how I got from here down to there? Okay, so now we're going to split this up, and we'd have W equals -3 plus the square root of 5 over 4. W equals -3 minus the square root of 5 over 4. And then we're going to do an approximation. So for the top one, I'm going to have parentheses -3 plus the square root of 5, close parentheses, divided by 4. So I've got parentheses -3 plus the square root of 5, close it up, divided by 4. And for that one, I'm getting -0.19098, etc. So rounding to nearest hundredth, I would get what? -0.19. Okay, so that's that answer. Then this one, -3 minus the square root of 5 divided by 4. And let's see here. I'm getting -1.3090. This 9 is going to round up, so I'm going to get -1.31. So here are your exact answers and your decimal approximations to the nearest hundredth. Any questions about that? All right, next we're going to look at some examples of quadratic equations that are in standard form, but there's some things we can do to make them easier to deal with. And we're not going to go on and solve these examples. We're just going to look at the steps that will simplify them. All right. So first of all, let's say I've got this one, -5x squared plus 9x minus 2 equals 0. This is in standard form, but notice that a is -5. And in your quadratic formula, everything's over 2a. It's just nicer to have your leading coefficient positive. So what could I do to make that happen? Well, what I could do is this. I could multiply both sides by -1, and that would give me 5x squared minus 9x plus 2 equals 0. And then from there, a is 5, b is -9, c is 2, etc., etc. So you could multiply both sides of the equation by -1 to get a to be a positive number. All right. Another example. Let's say you've got 1.6 t squared plus 2.4t minus 0.9 equals 0. Well, again, this is in standard form where A is 1.6, B is 2.4, and C is negative 0.9. And you could plug those into the quadratic formula. It would work, but it might be easier to get rid of the decimals. Since each of the terms has one number to the right of the decimal point, I'm going to multiply both sides of the equation by 10. Multiplying by 10 moves the decimal point one place to the right. 100 would move it 2 places, 1,000 3 places, etc. So now I get 16t squared plus 24t minus 9 equals 0. So A is 16, B is 24, and C is negative 9. And you could plug those into the quadratic formula. All right. Any questions there? Let's say we've got an equation with fractions. 1/8 x squared plus 1/2 x minus 3/4 equals 0. Now, I don't think we've done this in Math 93 this quarter. This actually goes all the way back to a beginning algebra, Math 85, or wherever you took beginning algebra. But we can deal with the fractions. We could say A is 1/8, B is 1/2, and C is negative 3/4. Things get really messy if we do that. Better to clear the fractions. So what I need to do is I need to look at each denominator. This has got an implied 1 denominator, okay? What is the least common denominator of 8, 2, and 4? That would be 8. So now I'm going to multiply both sides of the equation by 8. So distributing, I get 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4 equals 8 times 0. And I put that minus sign out here in front. I could have written plus 8 times negative 3/4, same thing. But now going across and reducing, I get x squared plus 4x minus 6 equals 0. So A is 1, B is 4, and C is negative 6. I'll get the exact same answer using those numbers as I would have using those fractions. So I can find the least common denominator of all the fractions in the entire equation, both sides of the equal sign, multiply through by it, reduce it out, get rid of my denominators. Okay. And let's see here. One more example. Let's say I've got this 33y squared plus 99y minus 66 equals 0. Well, if you look at 33, 99, and minus 66, does there seem to be something that's common to all three of those numbers? Can you think of a large number that goes into all three of those? Anybody?
33.
33, good. So what if we divide each term on both sides of the equation by 33? We'd get y squared, y squared, plus 3y minus 2 equals 0. So now A is 1, B is 3, C is negative 2. We can go to the quadratic formula, nicer, smaller numbers, okay? It doesn't always turn out there's something we can reduce out, but if there is, it's probably going to be easier to take that, to reduce that out first. Okay. So if we've got a leading term that's negative, we can multiply both sides by -1. If we have decimals, multiply by 10 or 100 or 1,000, depending on what's necessary. If there's fractions, multiply both sides by the least common denominator. If there's a common factor in all the terms, divide by that, divide each term by that to reduce it down. Okay. So now let's take a look at some more examples here. We have x squared equals negative 5/4 x plus 3/2. It says solve each equation, approximate the solutions to the nearest hundredth when appropriate. All right, So the first thing I'm going to do is get this thing in standard form. So I'm going to add 5/4 x to both sides, and I'm going to subtract 3/2 from both sides. So now I've got x squared plus 5/4 x minus 3/2 equals 0. So my equation is in standard form. Ax squared plus bx plus c equals 0. But I have fractions. I want to get rid of them. My denominators are an implied 1, a 4, a 2, and an implied 1. The least common denominator of 4, 2, and 1 is 4. So I'm going to multiply both sides of the equation by 4. So I get 4x squared plus 4 times 5/4 x minus 4 times 3/2 equals 4 times 0. Any questions? All right. So this becomes 4x squared plus 5x, the 4's reduce out, minus 6, 4 over 2 is 2 over 1, equals 0. Okay, so now my equation's in standard form. Sorry, I'm all by myself here. And the coefficients are integers. It gets lonely in this basement. All right, so we've got, let's see here. A is 4, B is 5, and C is -6. Okay, so x equals -5 plus or minus the square root of 5 squared minus 4 times 4 times -6 all over 2 times 4. X equals -5 plus or minus the square root of 5 squared is 25. 4 times 4 is 16, but it's -16 times -6, which would be a positive 96. 16 times 6, all over 8. X equals -5 plus or minus the square root of, let's see, what is that? Is that 121? All over 8. X equals -5 plus or minus the square root of 121 happens to be exactly 11, all over 8. So now I've got x equals -5 plus 11 over 8. X equals -5 minus 11 over 8. But this would be, see, -5 plus 11 is 6 over 8, or 3/4. -5 minus 11 is -16 over 8, which is -2. So x equals 3/4 and -2. Now, the directions said, let's see, where do they go? Approximate the solutions to the nearest hundredth when appropriate. These come out exact, so there's no need to approximate them. They would be exactly 0.75 and exactly -2 if we went with decimals. So that's all the further you'd go with that problem. But here we put it in standard form, we cleared the fractions, etc. Okay, let's see here. Let's take this one. We've got x times x minus 27 equals 280. We need to get this in standard form. So on the left side of the equation, we're going to distribute the x. We get x squared minus 27x equals 280. Now we'll subtract 280 from both sides, and we'll get x squared minus 27x minus 280 equals 0. Okay, so now it's in standard form. Well, there's no decimals to clear, there's no fractions to clear, there's nothing common to all of them that we could divide out. So we're ready to go with a quadratic formula. A is 1, B is negative 27, and C is negative 280. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative times negative is positive 27 plus or minus negative 27 times negative 27 is going to be positive 729 minus 4 times minus 280 would be plus, let's see, 4 times 280 is 1120 all over 2. So x equals 27 plus or minus the square root of, let's see here, 1120 plus 729 is 1849 all over 2. Now, before I try to see if I can simplify 1849 and break it down somewhat, I'm going to go in with the idea that maybe it's a square. So I'm going to take the square root of 1849, and it comes out to exactly 43. That's not always going to work out, but it does in this case. 27 plus or minus 43 all over 2. Okay. So then x is 27 plus 43 over 2. X is 27 minus 43 over 2. Let's see, 27 plus 43 would be 70 over 2 is 35. 27 minus 43 is negative 16 over 2, which is negative 8. So x equals 35 and negative 8. Again, no need to do decimal approximations because those come out to exact integers. Let's see here. How about this one? X squared over 8 minus x over 4 equals 1/2. So to put this in standard form, I will subtract 1/2 from both sides. So I get x squared over 8 minus x over 4 minus 1 over 2 equals 0. The least common denominator is going to be 8. So I'm going to take 8 times x squared over 8 minus 8 times x over 4 minus 8 times 1/2 equals 0. Going through and reducing, the 8's reduce out, x squared. 8 over 4 is 2 over 1 minus 2x. 8 over 2 is 4 over 1 minus 4 equals 0. So I've got it in standard form and I've gotten rid of my fractions. Okay. A is 1, B is negative 2, C is negative 4. So x equals negative b plus or minus the square root of b, the quantity squared, minus 4ac all over 2a. X equals 2 plus or minus the square root of negative 2, the quantity squared is 4, minus 4 times 1 times minus 4 is plus 16 all over 2. X equals 2 plus or minus the square root of 20 all over 2. But the square root of 20 is the square root of 4 times 5 is 2 square roots of 5. So x equals 2 plus or minus 2 square roots of 5 over 2. And all that, I'm just continuing to simplify. I'm going to take this and copy it on the next page. X equals 2 plus or minus 2 square roots of 5 all over 2. I'll go back here in case anybody still is frantically copying things down there. So now looking at this and this and this, I can see that they all have a 2 in common. So I could say X equals 2 over 2 plus or minus 2 square roots of 5 over 2, splitting up the 2 terms in the numerator over the denominator. We did that way back in chapter 5.7 or 8, I think it was, earlier on this quarter. So then this becomes X equals 1 plus or minus the square root of 5. So X is 1 plus the square root of 5. X is 1 minus the square root of 5. And then going to the calculator, 1 plus the square root of 5 is approximately 3.236. So that would round off to 3.236. So that would round off to 3.24. And then let's see, 1 minus the square root of 5 is approximately negative 1.24. Again, rounding to the nearest hundredth. So you go to the thousandth place, 5 and above rounds up, 4 and below rounds down. All right. So here we have 2 exact solutions, 2 decimal approximation solutions. All righty. Well, that's it for today. I will be back at 1:15 if you have any questions. So I'm going to stop the recording.